Here we have a question from JEST 2024. We are given Maxwell distribution function Cv square exponential minus 1 by 2 beta mv square for molecules of ideal gas in equilibrium at inverse temperature beta. We have to compute v raised to 4 expectation value the whole raised to 1 by 4. I will use the letter f for denoting distribution function because p is used for probability and probability is given by f of v times dv. Only if we multiply distribution function by dv, then we will get p. Now to get the average value of any quantity on particles, we will integrate a. If we want average value of a, we will multiply a by f of v dv, or you can say we will multiply by p, then integrate it from 0 to infinity. Then we will get the expectation value of a. If you want expectation value of v square, for example, you will multiply v square by f of v dv, or you can multiply by probability, both are same, and then you have to integrate from 0 to infinity, then you will get the expectation value of v square. So let us find out the expectation value of v raised to 4. Expectation value of v raised to 4 will be equal to integral 0 to infinity v raised to 4 times f of v dv. F of v is given here, distribution function. Therefore we have integral 0 to infinity v raised to 4. And what is the value of c? Because we are familiar with this function already, we know the value of c is equal to 4 pi. This is coming from the integration of solid angle times m divided by 2 pi kt the whole raised to 3 by 2. So if you put the value of f here in the integral, we will get 4 pi times m by 2 pi kt the whole raised to 3 by 2 times v square e raised to minus mv square upon 2 kt. Beta is 1 by kt. Then we have dv here. Therefore we have v raised to 4 expectation value is equal to, we are taking constants outside, 4 pi times m by 2 pi kt the whole raised to 3 by 2 times integral 0 to infinity v raised to 6 e raised to minus mv square upon 2 kt dv. Now this integral, it is in the format integral 0 to infinity x raised to 2n e raised to minus ax square dx. This is a standard integral and is equal to 2n minus 1 double factorial divided by 2 raised to n plus 1 a raised to 2n plus 1 by 2 times root by. When we compare the standard integral with this given integral, we see that n is equal to 3 here and a is equal to m by 2 kt. Therefore we have, let's say this is integral I, then we have integral I is equal to 2 into 3 minus 1 double factorial divided by 2 raised to 3 plus 1. A is m by 2 kt, m by 2 kt the whole raised to 2 times 3 plus 1 divided by 2 into root by. How will you find out double factorial here? Double factorial is defined as, for odd numbers it is 2k minus 1 double factorial. This is equal to 2k factorial divided by 2 raised to k into k factorial. Double factorial of even number is 2k double factorial. This is equal to 2 raised to k times k factorial. Let us find out the value of 2 into 3 minus 1 factorial. Double factorial, this is equal to 6 factorial. 2 into 3 is 6. 6 factorial divided by 2 raised to 3 times k factorial. K factorial is 3 factorial, which is equal to 6 factorial is 6 into 5 into 4, 120 divided by 2 raised to 3, which is 8. Therefore we have this value, this is equal to 15. I becomes 15 divided by 2 raised to 3 plus 1, this is 2 raised to 4, which is 16. 16 times m by 2 kt the whole raised to 2n plus 1 divided by 2, which is 7 by 2. And then we have root pi here. This is the I value. Now let us find the value of v raised to 4 expectation value. This is equal to I times 4 pi times m by 2 pi kt the whole raised to 3 by 2. This is equal to m by 2 kt the whole raised to 3 by 2 minus 7 by 2. Minus 7 by 2 is from this I, and then we have 15 by 16 times 4 times pi raised to, there is a pi here, and then there is a root pi in the I, and then there is a pi raised to minus 3 by 2 here. So total pi raised to 1 plus 1 by 2 plus 1 by 2 minus 3 by 2, which is 1 plus 1 by 2 is 3 by 2, 3 by 2 minus 3 by 2 is 0. So pi raised to 0 is 1. So this is equal to 1. Therefore we have v raised to 4 expectation value is equal to m by 2 kt the whole raised to 3 by 2 minus 7 by 2 is minus 2. So we can write it as 2 kt upon m the whole square. And then we have 4 by 16 is 1 by 4, and then there is a 15. This is equal to 2 square and 4 cancels, so we have kt upon m the whole square times 15. This is the value of v raised to 4 expectation value. We need to find v raised to 4 expectation value the whole raised to 1 by 4, which is equal to kt upon m the whole raised to 2 divided by 4 times 15 raised to 1 by 4. This is equal to, let's write here, this is equal to root under 15 times kt upon m. Therefore the correct answer here is option A.